In order to use a proportion to solve a geometry problem, I first need to set up a true proportion. In this first example, we're told that segment MN relates to segment RS as segment NP relates to segment ST. So the first proportion that I could set up is just plugging in the values for each of these side lengths. So MN is 8, and RS is 10, and NP is 4, and ST is X. So the first proportion that I can write is just plugging in the values. The second proportion I can write. Now I want to keep equality. In order to keep equality, one of the things I can do is I can take the reciprocal of the left side. Instead of 8 over 10, I switch it to 10 over 8, as long as I take the reciprocal of the right side of my equation. If this is true, then this is also true. The third thing that I can do, in these two proportions, I'm relating a side to a side of two different triangles. I can stick within the one triangle. So I could say MN relates to NP. 8 to 4 relates to 10 to X. Notice that when I look at my proportion, in my numerator, 8 and 10, I've kept this ratio. And in my denominator, 4 and X, I've kept this ratio. 8 to 4, 10 to X. This proportion is also equivalent. It's also true. Let's use that concept to solve for a missing length. I need to find BA. Well, in order to find BA, I'm going to first find BDX. So I'm going to redraw these two triangles. I have a small triangle, B, D, and E, where my side lengths are X and 12. I also have a larger triangle, BAC. AC has a length of 16, and BA has a length of X and 3. So I want to make sure I write BA as X plus 3. A lot of students mistakenly will write this as 3X. I don't want to multiply these two lengths. I want to add them. So if I look at my directions, I can set up a proportion. BD over BA equals DE over AC. So I'm going to do that math. I'm going to set up my proportion where I have BD, which is X, over BA, which is X plus 3, DE, which is 12, over AC, which is 16. At this point, I have a proportion with an equal sign. I can solve. I can drop my equal sign straight down and cross multiply. 16x equals 12 times x plus 3. Notice that x plus 3 gets put into parentheses even though it didn't have parentheses here. I'm taking 12 times this entire denominator. So I need to add in the parentheses. So I get 16x equals 12x plus 36 after I distribute. Subtract 12x from both sides. 4x equals 36. Divide by 4. And I get x equals 9. Now it looks like I'm done here. I solved for x, I got x equals 9. But if I read my original instructions, I need to find the measure of BA. Well, if I want to find the measure of BA, and I know that x is 9. BA is going to be 9 and 3 for a grand total of 12. So my final answer is the measure of segment BA equals 12, 9, and 3.